that only way you can improve it is very early in the life cycle of the system. Conceptually, something has to be good. It's like having society, engineering system. If conceptually it is flawed, you cannot fix it downstream. So you can look at the quality like reliability, then you say, how can we improve our reliability? Sometimes we show this kind of a slide in Department of Defense, where they spend, USA has like about $650 billion budget every year in defense. So what it says is that in the beginning, if you look at what we call as total life cycle cost. So anytime we say, what is the cost of ownership or buying a weapon system? You could do the same thing in a company, in your house. If I buy this projector, not only the acquisition cost, but what will it cost me to run and operate for the next 5 years? Like you buy a washing machine, what is the total cost, not just the cost of ownership. And in the beginning, hardly we have spent much money during research and development, but the decisions that we make in the beginning dictate almost 90% of the life cycle cost. So more you focus up front, better off it will be. So like you were asking, so it is too late once you design something, then how you, after you release it to the customer, how you can improve it. But that doesn't mean that we should give up. So idea is that in the beginning, it is very, very critical. In the end, these things still have some impact, but very, very little impact on the total life cycle cost. So that is the purpose of this slide. And I think this slide focuses on a feed forward or focusing on doing design of experiment to change the inputs rather than to change the output by inspection and then giving feedback. And this is like a basic, I think this morning I showed this slide. We said, in any system or process, there are inputs and there are then noises. These are uncontrollable. And then some noises we decide not to control, and some we don't even know what they are, unknown noises. And then how do we optimize a process? Only thing that we can control, decision variable, are the control factors. For every design, you have to decide what are the control factors. And this re-emphasizes the distinction between control versus inspection. So we say, even if you believe in inspection, don't inspect the output, but inspect the input. So that way you can be proactive. And this one shows again, like sometimes people make a diagram like that. It says, what is the cost to fix a problem? It says in the beginning, this may be $1. In design, the same cost may be $10. In design, the cost to change is very, very small. All I need is a paper and a pencil, maybe a computer. I can rechange the specification. But once I release it in production, now they already have come up with manufacturing processes to make my part. Then if I tell them I change my specification, then cost is very high. And if you give the product to the customer and then get it back from the customer or send repair people to customer's home, their cost is very, very high. So the idea is most of the quality reliability program emphasis should be very early. Here you are more focused on fixing problems, and typically that is too late. Sometimes we say that if you look at a company, we say quality effort. So they do very little quality effort in the beginning, but they are spending a lot of money on solving problems. But what is the ideal? Ideal is I should spend more money in the beginning so that I don't have to solve problems. Then all the money that I will save from not solving problems, right, is much better than to keep on solving problems. Now the challenge is, if this is the reality and this is the ideal, how can we go from reality to the ideal? And what is preventing us from going there? As human beings, what is preventing us from going there? So like we talk about societies, political systems, so why it is that we are stuck with solving problems? Why you think in our life, in any society, people are stuck with this reality on solving problems? Why can't they invest more money and time to be proactive? And it is even true with yourself as an individual, right? How much we teach people, oh, don't eat too much, do exercise, do this, but people violate it all the time. And then they spend thousands of dollars in health care, right? And then they suffer, and then their families suffer. But question is, what is preventing people? There is enough science to say that it's just like there's a physical input-output, right? If I put a lot of energy, calories in my system, something will happen. They're not going to disappear, no? But people keep on eating. Why is that?
They want momentary enjoy.
Very good, yeah. So what he says is, see, this is, the question is, why do we do that, and how much damage there is in society or in the system. So the idea is, if you have a system, like we always make a box, and then we say there is some response variable y, and then we can give a feedback. And for our discussion in evolution, we can look at a negative feedback, or we can look at a positive feedback. So the way, this is just a concept, doesn't mean this is the truth. So the way evolution happens, like in biology, so this is like we're talking of biology. So we think nature, just like we're talking of, how do you change a human behavior, right? So most of you said, oh, people, it's very hard to change people, and they're all stuck. So then the simple question is, how could I change people? And nature had to learn how to change people. Yes, no, the idea is, as the environment changed, like on planet, at least scientists think planet environment was very different million years ago than it is today, and it will be very different million years from today. So then people will have to adapt, right? If we don't adapt, we will perish, all of us perish. So for basic life, nature says you want to sustain life, if that is one function, right? Whether it's given by God or whoever. So the function is you have to live. For you to live, I want to change your behavior so that you will live. Very simple change of behavior. Nature says, oh, that's so simple. I will design you so that when you will eat, you'll feel very good. So idea is that the only way to change people inherently, biologically, is to give them positive reinforcement. You enjoy it, you have pleasure, you have happiness. It's not like when you eat and you suddenly, feel very bad or it starts hurting. So it is not negative feedback. This is what you call as positive reinforcement. Like, I reward you, I appreciate what you do. And he says that is the best way to change behavior. In our society, or even United States, all over the world, we punish people to change their behavior, right? How many people every day we put in jail, and for how many thousands of years we have been killing people who we think are bad, right? And but you think bad people have become less after 2,000 years of killings? No, it's same. So it is empirical evidence. This is what you call as a scientist. The empirical evidence says if you punish people, you have very little effect on changing their behavior. But if you reward them, then the negative flip side is now you get too much pleasure. So then you can get addicted to pleasure, right? So then, like, you can overeat and then you could get sick. So then just like you drink or you take drugs for recreational purpose, you get temporary high, so you get too much pleasure, but then you'll suffer later on. So nature did something very good. They gave us positive feedback to change. And it was very effective. Eating food was so effective for us to live. Everywhere you look at all the animals, some animals whole day spent on eating, right? Like you look at birds and they're just hunting and to pick something here, something there. And that drive is so strong that they're willing to almost do anything. What else is important for us to live? Our reproduced life, right?
Air, water,
food, yeah. But to reproduce, we need sex, yes? Yes, no? There are different ways to reproduce, right? So then there is a positive reinforcement or negative reinforcement. Some of you are too young to know. You're married?
Yes.
Yeah. So it is good or bad? Positive reinforcement. Then it is so positive that people keep on doing it, right? So if you calculate in your own life how much sex you have and how much was needed for reproduction, 99% of the sex has nothing to do with reproduction, right? It's such a positive reinforcement. And then all the abuses people have, like all you do is look in India and read the paper, how many rape cases are there and sexual assault, and your university has all kinds of rules about harassing girls and so on. So idea is that the reinforcement is so strong. Nature designed it to be strong because otherwise people won't have sex, right? But then the flip side is people don't know how to manage and they become addicted to it, right? Or whatever the right word may be. So it is then, those are the negative consequences. So same idea in here, you could say people are very short-term oriented. So short-term you get a high, but long-term it has very negative consequences. So I want to save money in my company, I want to increase profits this quarter, and I don't want to invest, but I'm not worried about next quarter or next year, and I take away money from R&D, because then my company has a lot of profits to show. But 10 years from today, I'm not smart enough to know that my company will become bankrupt. So there are many, you could almost do so much research on why people work the way they work. But at least some empirical evidence is that if you want to change people's behavior in America or India or China, you cannot do it by hurting them. Make sense? So then the question is, how could you provide positive reinforcement? Like as a teacher, we hurt students, right? By giving them bad grades and so on. So much better is positive reinforcement rather than creating fear in the classroom or with the group and doing depending on negative. We always tell them, oh, if you don't do this, this bad thing will happen, this bad thing will happen. But rarely we do is, oh, if you do these things, these good things will happen. So you have to focus on building social systems and changing human behavior based on positive reinforcements. Like all of you know that you can apply this idea, how do you motivate employees in a company? So every company will tell you, oh, you can't punish them, but you have to praise them and you have to reward them, and I give you salary and I give you bonus and I take you out to dinner and we love your family and on and on. So only way you can win loyalty is based on positive reinforcement. But you have to apply it the same. But most of these in our societies typically happens is, if I do something bad, right, so I kill a person, what is the meaning of justice? That you kill me, right? So is that justice? Revenge, yeah, like Gandhi even said that, right? Or even, Jesus said that 2,000 years ago. An eye for an eye, doesn't work, right? But nobody is listening. How much fear we create in any society, even in a company, in a university, and it is not based on positive reinforcement. So how you create a system where people are having fun and enjoying, rather than motivating you because I say, oh, if you don't do this, I'll fail you in this course. It doesn't have any effect, right? People still don't study. Even if I threaten that I'll fail them, some of the students still won't study, right? So it doesn't work. So this is another way to think about safety. Like we say, that if you go home today, some of you who drive, how many near misses you will have? You are suddenly driving and you are only 4 inches away from the other car, right? So, and then one of these days, this near accident will become in a minor injury. Then one of these minor injury will become a serious injury. Then one of the serious injury will become in death, and so on. So there is a hierarchy like that. You could make a very big pyramid depending upon where you want to start. So somebody says, I want to minimize a serious injury. Can you just cut the top of the pyramid? No. Only thing you can do is focus at the bottom. So focusing at the bottom means you prevent near accidents. And more near accidents you prevent, then fewer minor accidents will happen and fewer serious injury will happen. Then I say, how do I prevent near accidents? So now at least we have technology like collision avoidance, right? In new cars, we have hundreds of sensors in any car. It will tell you who's nearby you. We are now so smart that we don't even need a driver who can make mistake. So you could have a driverless cars. So you're using technology and training and educating people at the lower levels. If you reduce the base of the pyramid, you will reduce the top of the pyramid. So you cannot just tell somebody, oh, just in India, like somebody could say, oh, let's reduce the number of deaths by 10%. That is government's new objective. That is a very bad policy. Because you cannot reduce it like that unless you are focusing on redesigning vehicles in India. You are training people to stay in their lane. You are training people's culture, right? You are changing the designs of the car. You are putting all the safety equipment in the car. So you have to do zillions of things to reduce the number of deaths at the high level. So that's the basic. You can apply the same idea of this pyramid for quality. So you say that you cannot get rid of this. That is impossible, but this is possible, right? That's the basic idea. So that's why all the education on driver safety is important, redesigning cars is important, redesigning roads is important, redesigning traffic signals is important. Maybe very important to change culture of people. Why in India nobody follows their lane?
There is a lot of corruption in giving license.
So everybody says, why should... People are so greedy, like we use that word.
Educated people
Not
doesn't
proper
know
training
which
is
is their exact lane, sir.
I know.
I, after driving 3 to 4 years later, I saw that there is a specific lane. Slow moving traffic, heavy moving traffic and overtaking. We don't know and nobody teaches us.
There is not proper training.
But this is so simple. The lanes are there. All you do is stay in your lane.
No, we
People
keep
don't
on
know
changing lanes.
what the meaning of a lane.
We don't know.
Road is raised.
Lane doesn't mean, sir.
Ah.
What we need for driving is the open space.
Ah.
We see the open space in
Sure,
nearby lane,
yeah.
we immediately shift to that and then again shift to...
I know what you do. That's why I'm so afraid to... I don't drive, but even go with somebody, because the risk is very, very high. Like I mentioned before, and you can Google it. I think you did that too. So the hazard rate, accident rate in India is 10 times more per mile driving than United States. And who knows what the real increment is. So if the statistic says it is 10 times, so much data is not reported. So it could be a lot higher than that. But that is just a simple thing. I remember one of my brothers came to visit us and he was just looking at people on the road, right? So there's hardly any traffic and there's a stop sign. A car will come and stop right there. There's no car there, there's no car here. It's all vacant, but the car is stopped. So my brother says, what is wrong with this person? Why would you stop? Because even if there is nobody else there, right? So the instinct is you follow the rule, because not that we are saying that is the best thing to do, because then rules impact everybody else. And if you don't follow, then you have no idea what somebody else will do. So like we do that, we will not even if you're sitting in your driveway and you want to back out, you cannot start the ignition unless you put seat belt. Instinctively, you can't do that. It will say something is wrong here if I don't do that. But our system is very chaotic. But then society is paying a tremendous price for it, right? In death and injury, and how many families, if their parents get affected, their brother, sister get affected, then they will suffer because of these issues. So then the idea is that you need a design management in a company. So we say in design management, if you give me the right information at the right time, the key word is rational. If I'm rational, I will make the right decision. Then the purpose of a reliability, safety, quality department is to provide this information so that designers can make the right decision. That's the idea. So that's why you need a reliability department or safety department. And we learned that reliability, safety is one of the qualities. Objective is not to make something very reliable, but you want to increase reliability or change reliability in the context of the whole system. Because if you change reliability, you will change many other qualities. So it could also have a negative impact. And you need an organization. Many organizations do what is typically called a cost-benefit analysis. You have heard that word, cost-benefit? Yes, no? We say what is the cost of doing something, and then what are the benefits. You think we should do cost-benefit analysis? Should we do? You know what it is? Yes, no, maybe. Before you can answer whether we should do it or not. You know what it is? You never heard of cost-benefit analysis? How about people in the back?
Yes, sir.
What is it? What is cost benefit?
By seeing the voice, we can imagine what it is, what it is. I didn't study. I don't know.
No. So the idea is that anytime you do something, right, there is a cost. And then somebody says, you're spending this money, then what are the benefits, whether it is worthwhile spending the money. If I spend $100, but benefits to me are $80, then I say that's not worth doing.
Depends on the product or service we are providing.
Sure, yeah.
If it is for the saving of humanity or service of humanity, it won't be of much interest that how much cost we are incurring. But if it is a manufacturing process, then everybody thinks that we have to incur less cost and to earn more benefit. So it depends on the process, service or the product.
But I think the key idea is whether we can truly estimate the cost and whether we can truly estimate the benefits. Cost is relatively easy to estimate. Benefits are almost impossible to estimate. So it's like, a Ministry Human Resources of Government of India. So they have this program, right, GYAN. So they spent, you could say, we could calculate how much they spent for me to teach this course, right? But what is the benefit? Can they calculate? Yeah. First question with benefit is, benefits to who? Right? In education, you can never answer that question. Is it benefit to people that sat here, or benefit to your university, or benefit to India, or benefits to the world? And the harder question to answer is benefits for how long? Am I worried about benefits this year or for next 100 years? So remember, in teaching, if you transform a student, you change the future of humanity, right?
Similarly, like with Mangalyaan.
Oh, okay.
$74 million approximately we have spent it. Till now, people doesn't understand what are the benefits.
What are the benefits?
But they will be definitely providing some benefits in the upcoming 100 years.
Sure. Education is something you cannot do cost-benefit analysis. Education is almost even deeper than religion. You just believe in education. Somebody says, why education? The basic idea is very simple. If you don't educate people, what will happen to humanity? Anybody?
They will also be like animals.
Yeah, you'll disappear very soon. You won't innovate, you won't learn, you won't grow at all. So if you refuse to do, then no new technologies, no innovations. So it is something that you just believe in. It is not something you could say, oh, I want to do BTech and my expenditures at 5 lakhs. Your parents cannot say, oh, are you going to make more than 5 lakhs when you start working? That has no meaning, right? That has no meaning. If education is a business model, then people try to calculate that. And that we learned this morning was the wrong thing to do. Because education is not a business model. Sometimes, safety reliability is very complex, so we focus on numbers. So we do what we call as quantitative, but many times we don't look at quantitative, but we make it qualitative. What qualitative means is that, there is no way to know how much you have improved a system, because something can fail, say, in 100 ways. And if I get rid of one failure mode, somebody says, oh, how much impact you have on safety, reliability? Nobody can calculate it. So the basic premise is that you continuously keep on improving the design. It says any failure mode, either predicted or actual, if you eliminate it, it will result in high reliability. So you keep understanding how things can go wrong, hundreds of ways they can go wrong, and then keep on preventing them again and again and again and again. So that's the basic idea. Then we can talk about many methods to do that, like design review, which is like done by a team, failure mode analysis, fault tree. You heard of fault tree? Anybody? No? Okay.
Yes,
Somebody has heard of fault tree. Then you can talk about safety factor approach or probabilistic approach. We can do a lot of testing to improve the reliability. So there are many things that we can teach. So there are a couple of comments given how in many companies we do design review. Then it's a formal process. Then we can use, so there are two kinds of methods. One is induction, other is deduction. Do you know the difference between induction and deduction? Induction and deduction. You have heard those words? Yes? So what's the difference?
So induction is the process prior to the starting of any process. And deduction is the making some type of process short or eliminating some of the process or any time.
Anybody else? Induction versus deduction.
Deduction is something induced.
You deduce something. Sure.
Deduction is it deducts some amount. But I don't know how to implement it.
How to in reliability. See, there are two ways students learn, and you could say this is how people learn. So some students learn by example. So then I teach them one example, then I teach them second example, then I teach them third example, and then they start seeing a pattern, and then they can formalize some principles. So many times professors say, or people say in education, people that do that are very low level. People like Einstein don't go through example. They think at a very higher level. And then once that principle they can understand, then they can deduce all kinds of things in physics and chemistry and so on. So the basic idea is deduction constitutes reasoning from very general level. So if you want to apply in reliability or safety, supposing an airplane has crashed, then somebody says, oh, let us do the analysis or post-mortem, see why did it crash. Now I try to deduce why airplane crashed. Like somebody dies, medical department can cut them up and figure out why did they die. So that is the deductive approach. Induction would say opposite. I take general thing, I look at you, I see your blood pressure is high, your cholesterol is high, your glucose level is high, and then I try to generalize it and say, hey, if this is happening, one of these days you will die. So I then go to death from large number of things, failures, and then deduce how it will result in a catastrophic event. But deduction is after somebody has died, and then we figure out why they died. Make sense? It's like in mathematics you learn induction and deduction. Somebody says prove some equation, and for a squared something and b squared something is c squared something. So it says, can you prove it is true for every n? So then one way they do that is, let us say it is true for n equal to 1. Then you say, oh, it's true for n equal to 2. Then you say, is it true for any n? Then you prove, is it true for n plus 1? And then you say, oh, if it's true for n, and then it is also true for n plus 1, then n can be a billion. So then you say, oh, QED, it is true from every n, right? So you go from specific to the general. Another is to go from general to the specific. So that's the idea of induction. So many people like induction and some people like deduction. So there are two approaches. Then these methods, we sometimes in safety, in a systems approach, we call them, like in deduction, it is top down. Airplane has crashed, and then I say, oh, this knob caused the plane to crash, or this microprocessor caused the plane to crash, or this software caused the plane to crash. But in induction, we start with every nut and bolt, and then I say, if this nut fails, how will it affect the subassembly? If the subassembly is affected, then it will affect the system, and then something bad will happen. So that is, we call it as the bottom-up approach. So one is top-down, other is bottom-up approach. So you can look at that. In one approach, you go from causes to consequences, from the lower level causes, and then you say, oh, these causes will result in consequences. In another approach, you go from consequences and then you deduce the causes. Fault tree is a deductive approach. You start something at the top level, which is some undesired event. This is very, very important in maintainability, like in your project. So then you can figure out, why does a machine fail? And if machine is not working, now you have to have a logic tree. You have to say which part is bad. And then you can repair that part, right? So that's why in machines, or in a car, or in an airplane, we have millions and millions of sensors. And they can diagnose, and then where the fault is, and then you can fix it. So that's the idea. So there are many methods that we do in reliability that are like inductive methods, and then there are methods like fault tree, that is a deductive method. Fault tree. So FMEA is a inductive method because you look at failure modes at component level, and then you postulate how the system can fail. Right? You follow that? At a component level, then but then we could do fault tree where we do the opposite. Then there are all kinds of FMEAs. This is one example of FMEA. And then you can do criticality analysis. So you can see, we could teach a whole week course how to do FMEA. So it's a pretty complicated topic, so we won't go through all the details. So the basic idea always is that it starts with the failures, and it starts with at low level, and then it induces the effect on the next level, and the next level, and the next level. So I think we can kind of skip through, but you get an idea of what is failure mode analysis at a very, very basic level. So then we can, I think this risk matrix means is that you look at failure modes, then you say, if this thing fails, how much damage can we do to the system? But then with what probability that thing can fail? So if something has high severity and high probability of happening, that thing will be very critical, right? If something has very low probability of happening, and if it fails, nothing big happens, that is a low priority. So you can develop your Pareto analysis or priorities very good. Yeah. So it gives you some idea of what is FMEA. But then FTA is a lot more complicated. So that is based on binary logic, so what we call as Boolean algebra. And then you can start with the top event, and then you have logic gates like AND and OR and so on. Yeah, so you could say logic gate is like many times in safety, like if there's a pilot doesn't listen to one signal, so you may have at least 3 signals to say there is fire. Then you could say, oh, at least 2 out of the 3 have to say there is fire, then I think there is fire. So you can develop all kinds of logic gate And that's many times how we design software and hardware for diagnostic purposes. You have a car and your car doesn't start. So then mechanic has to say, why doesn't car start? He says, oh, maybe you don't have fuel, or maybe your battery is dead, or maybe this is there, maybe this is there. And then you can go down. Ultimately, you'll figure out, oh, it was the generator, or the actuator, or this wiring, or this fuse. So we can...
Program is there on this car.
Program is there, yeah.
When crash
Yeah,
the car,
definitely.
lever
Yeah.
turn direction of the car. After so many
Sure.
transactions.
So it's like we send astronaut to hopefully 10, 20 years to Mars, or you have a space shuttle. Something goes wrong on onboard computer, you cannot send a mechanic to fix it. So the computer has all the diagnostic table built in it. And then suddenly computer will analyze itself and then send a signal on Earth. Oh, this part is bad. And then they'll figure out to switch on second part. So it all has to be done in the system. And that technology is very easy because it's all based on binary logic. And computers are very good with binary logic. Good? So I think that finishes a little bit flavor about improvement. Then tomorrow morning, we can focus on some modeling systems from the viewpoint of reliability. How do we model them and how do we analyze them? You have heard words like series and parallel and so on. And then we could say, how do you design system? How do we design systems so that everything is reliable? And what are the principles to design systems? So you guys have a nice evening, and then we'll see you tomorrow morning. Thank you very much. Thank you. Thank you.